All right, guys. So I have another example of a potential question that was coming up, and it was more around the electude part of one of the questions that you guys had. So I want to see if I can bring in this example right here so that you guys can see. And then on this, the question was, what's the voltage drop across these resistors? So the first thing that we need to do is we got to find the equivalent resistance of this. Now, looking at it, we can tell that it's a series circuit. So based on that, we can redraw this diagram. So I'm going to do that again, but I'm going to show you maybe. Let me see here. I'm going to show you a simplified version of the same diagram. I'm going to draw it over here in the corner, and what I'm going to do is the series circuit, right? We're going to write the same thing here, 12 volts. But we need to determine what the resistors are. So we add these three together, right? So we're going to add some of these units together, right? So we're going to add the 40 and then the 20 and then this 20 here, right? So in order to do that, we end up coming up with what? Well, that'll be 80 ohms. Okay. It's a little easier than a parallel circuit. Now, based on that value, right, we can now figure out the equivalent resistance, right? Or actually the current. We got the total equivalent circuit resistance is 80 ohms. So we'll use that same calculation, right? Ohm's law. And we got 12 volts is equal to, we don't know the current, right? Times 80, right? We'll divide both sides by 80. And this ends up being what? 0.15 it looks like. Let me just recheck that again. Pretty sure that is. Yeah, it's going to be I is equal to 0.15 amp. So that means that in this circuit, right, the current that's returning back this direction, right, from here is going to be 0.15 amp. And we know that the current coming up and out here is going to be what? Yeah, 0.15 amp. So now that we know the amperage, and that includes this one, right? It's the same circuit, just that we figured out the total circuit equivalency. So this would be 0.15 as well. Okay. Okay. So now that we figured that out, let's see if we can get rid of this. Here, bear with me a second. Sorry, guys, I'm still trying to figure out my app here. Now that we know our current that's going through this unit, right, we don't need this diagram anymore. But this redraw procedure, I think mentally it helps try to create the picture. So now, based on the fact that we know this, we can again use what? Yeah, well, we're going to use Ohm's law again. So V equals I times R, right? So for this first one, we know that we have what? We have 0.15 amps, and we have a 40 ohm resistor, right? And that should give us our voltage. And if we multiply this times 40, we get 6 volts, right? 6. So that means that if I was to plug in a meter, right, across this to right here, right, that reading would be 6 volts, right? That's how much my voltage drop is, or how much is consumed. Which leaves us what? Well, we started with 12 volts, right, according to this. So we still got 6 more volts. So then we go over to the next one, R3. In R3, we're going to do the same thing, right? Voltage is equal to I times R. And again, we got this 0.15 because what's our rule? Well, in a series circuit, right, current's the same everywhere, but in this case, our resistance is different, and that's going to give us our voltage. And you'll see that the next two are actually the same, so we're going to get the same voltage drop for each resistor. So this one comes out to 3, right, 3 volts. This one's 6 volts. So again, if I was to put my meter at this point and have it come up, right, to here, what would my reading be between these 2 points? It would be 3 volts, right? And then again, the same thing. At this point, we got the same resistance. If you do the calculation, you're going to come up with what? 3 volts. Now, to double check yourself, you just add those together, right? 6 plus 3 is 9, and 9 plus 3 is going to be 12, and our source voltage is 12. So that ends up making us what? Yep, we're all going to be pretty happy with that result, right? Which ends up happening. So it looks like our circuit is good, and we should be able to solve those series circuit equations for this voltage drop. All right, let me know if you have any questions. Thanks a lot, guys.